Hi guys, my name is Perlow from Zen Protocol. Today I'm here to talk about our project, which is trying to facilitate a decentralized financial system. But before I go into that, I want to go into talking about why to do this. So if you think of it, your whole life, you work, you save money. Part of the money you make, you spend on your living expenses, obviously, and the other part, you invest in order to maintain your purchasing power or in order to try to accumulate more capital. But the thing is that you're making artificially low returns on your money due to inefficiencies. Mainly the fact that there's excessively high fees, you can't diversify correctly, and there's unnecessary counterparty risk. So if you think of it and you say, for a given, let's say I make some sort of investment, I could buy a lottery ticket and make a million X on my money, but that doesn't make buying lottery tickets a good investment. It's only a good investment if you calculate the return adjusted for risk. So if you're saying for any given level of risk, is my investment a good one? And when you go ahead and you look at it that way, if you think of it that the market prices things efficiently, then you would say that for essentially there's no way that you can make more money without taking on more risk. Now, the thing is that these returns for any given level of risk that you choose to take are artificially constrained due to the high cost. So for example, say now I want to go buy a share of Tesla. Well, when I go ahead and do that, Tesla has a lot of burdens and regulation with SEC, whatever it is. They have to pass on those costs to me. Then I go to my broker. I say, hey, I want to place an order for Tesla. That broker is also facing a lot of regulations. He needs to make money. And again, those costs are passed on to me. And then the broker doesn't even trade directly versus Tesla. He has to go through an exchange, which also has regulation and has to make money and pass those costs on to me. The end result is that I'm making a lot less money for my investment. Now, earlier I talked about the fact that you can make a certain amount of return for a given level of risk. But that's not true when you're looking at your entire portfolio. So if you think of it, if you, let's say, hold a portfolio of assets which are uncorrelated, well, you could potentially increase your returns without necessarily taking on more risk. This is something known in the financial industry as like diversification, and the way it works is because you hold assets that aren't correlated. So I'll give you an example. Let's say I own a share of Apple stock, but I don't want to suffer from a potential downside risk, so I also buy a put option on Apple stock. And then with these two assets together, what I can do is I can create a situation where I have unlimited upside on Apple, but I have limited downside risk, and I can diversify my portfolio. The thing here is that my opportunities, my investment opportunities, are limited. They're constrained. And the reason that the assets that I can buy are limited are due to a few things. The first of them being the fact that which geographical area am I in? So for example, say I'm an American. As an American, I can't buy shares of Samsung because Samsung is traded on the Korean exchange. There are some solutions to this, things called ADRs or global depository receipts, that they can try to intermediate this global jurisdictional problem. But in general, you can really only buy assets that are in your local jurisdiction unless you're going through some sort of special broker. The other issue here, why my investment opportunities are limited, meaning that I can diversify my portfolio less efficiently, is the fact that there's regulations placed on me. So for example, if I'm not an accredited investor, I can't invest in startups, I can't take those bets and make those high returns because I'm not an accredited person like a VC. Or maybe I can't buy certain kinds of derivatives because I'm considered unknowledgeable, or whatever the reason may be. But these things can hurt me. Essentially, even if you think of it like home buyers, for example, they should have exposure to interest rate swaps, especially if they have a variable rate mortgage, but they can't get that access today. And the last issue is that there's a lack of creativity. So say, for example, I want to go ahead and I want to buy a different kind of financial instrument because I believe about some market aspect. Today, I can't do that because the people who can create these instruments have to be certain parties. So to give you a more practical example for the situations we're seeing in the market right now, let's say I believe that the price of the coin market cap will go down, the collective price of all the cryptocurrencies will go down, but I also believe that people are going to hedge out into stable coins. They're going to buy Tether, they're going to buy Trust Token, et cetera, et cetera. It's hard for me to take that kind of a combinatorial position today, but using a system like ours, you could easily create a derivative, a derivative that says, the ratio between the stablecoin market cap and the crypto coin market cap. And if it goes up, I'll make money. If it goes down, you'll make money. So essentially, what we're saying here is that if we want to increase the efficiency of our portfolio, the issues that we should address are the following three things. We should try to dispose of any third parties that eat into your returns. We should increase the diversification of your portfolio in order to get a better risk-adjusted return. And we should also reduce counterparty risk, essentially the risk that someone would say, hey, I'm going to pay you if we make this bet, but then they actually don't go ahead and pay you. So for those reasons, we've created Zen Protocol, which is a blockchain for finance. What we allow you to do is to, as mentioned, to easily create these new financial instruments which are backed by collateral. So in the example I previously gave about the stablecoin derivative, what I would do is I'd create a smart contract. I'd put $100 into that smart contract. You put $100 into that smart contract. That smart contract would issue two sets of tokens, bull tokens, bear tokens. And if it goes one way, the bear tokens make money. If it goes the other way, the bull tokens make money. And you can kind of take any sort of parameter, put this in, and create different kinds of derivatives based on different kind of underlying assets. Which no one is a party to except for you and your counterparty. The other thing that we are building and facilitating right now is to easily create new marketplaces to trade in these kind of exotic instruments. So I'll give you an example. Right now we're working with a company called Vinex, Vinex.wine, and what they do is they want to allow people who grow wine, wineries, to essentially trade off the risk. If it takes you, let's say, 2 years from the time that you pick the grapes, put them in the bottle, until you finally sell them at the store, then in these 2 years, there's like these capital flow situations where they can't get a loan from the bank because it's not good collateral. Wine, it doesn't, unlike real estate, it doesn't really act as good collateral. And there's also, there's no way for them to get over this issue. So what they want to do is to allow people to buy wine in advance. You pay for it today, you get the wine in 2 years, and then you can trade this wine forward. The issue here is that normally you would have to go through a lot of regulation under the CFTC, whatever that may be, and it's too small of a market for Vinex to exist normally. But using our platform, they can create a marketplace where people can buy and trade these instruments freely. And I actually view this to be one of the more interesting aspects of these kind of systems in the future. So what's different between us and, let's say, the other blockchain platforms out there today? So I kind of divided into there being three main blockchain platforms today, or families. You have Bitcoin and all of its forks, which they're all essentially like different architecture. They change a few parameters. And the thing about Bitcoin is that it's built as digital money. It only has one asset, and that asset can be moved to a person. It can be moved to like let's say a pay-to-public key hash, or it can be moved to a multi-sig or to a time lock. But that's essentially it. It's just one person where you can send that money one asset that can be sent to a few different limited kinds of locks. Then you have Ethereum, and in Ethereum, the way Ethereum works is a virtual machine. So Ethereum was designed to be this generalized kind of virtual machine. Anyone can come, they can program their decentralized application in. The thing is, it wasn't fit for purpose. It's not been built to be fit for purpose. A token on Ethereum is like an ERC20 contract, and the way that these applications are going to work on Ethereum is that you program your application into Ethereum, and then it's distributed around the world to these concurrent virtual machines that are running at the same time. I guess that the thing is that, as we've seen, nothing is going to really catch on in Ethereum beyond tokens, and that kind of makes sense, because what else justifies the cost of having everyone replicate the same database beyond moving our assets around? And so at Zen Protocol, a project we've been in the works quietly about for a couple of years, is a system customly designed for financial instruments. We have support for multiple assets at the protocol layer. So for the more technical among you, it's the UTXO model, but with support for multiple tokens. And these tokens can be held either by individuals or they can be held by contracts. But these contracts aren't the same kind of smart contracts you would normally refer to in a virtual machine. It's not some sector of the virtual machine. Rather, each contract stands on its own. And the reason that we can do that is because of the fundamental innovation that we've brought to market, which is the way that our system operates. So if you think of it in, let's say, Ethereum, the reason Ethereum had to build an EVM is because if you go ahead and you invoke a contract, let's say, a certain amount of times, you don't know how long it's going to take for that contract to run, to execute, to validate. So what you had to do is you had to build this gas system, which counts all the steps, and then you have to build this EVM where all the contracts sit, and all this computation is executed within the EVM, which counts these steps. But in our system, like in Bitcoin, you have a way to estimate or to predict the cost ahead of time. But unlike Bitcoin, you can have loops and recursion, and you can invoke a contract multiple times. And the way that we've done that is by proving ahead of time, prior to you running the contract, you can prove how much it would take, how long it's going to take to execute. So for example, you can say my contract takes, has a cost function of 3x plus 5. So if your transaction will invoke that contract once, it will cost 8. If you invoke it twice, it will cost 13, et cetera, et cetera. And by creating this system, we can have a contract paradigm which gets rid of a virtual machine, gets rid of gas, and where you essentially, each miner locally compiles that contract to their machine, meaning that essentially you have these things executing in a precompiled manner, which is a lot more efficient, and you have these things being able to be executed in parallel. So if you think about it, what does that mean? If you think about the difference between a CPU and a GPU can execute multiple things at the same time. CPU is, let's say, less efficient at doing so because it's not specialized to do parallel processes. In Ethereum, since everything has to be dependent on gas, it means that you can't really parallelize transactions. But with us, so long as the transactions are not interdependent on each other, then there's no problem for you to execute these transactions in parallel and gain a large amount of efficiency. There's other benefits to this system, such as having increased security, because everything is formally verified, or there's the ability to formally verify everything. The only thing we currently force you to do is formally verify your cost boundaries, which is how we got rid of the gas thing, and things like oracles that make it easier to create these financial instruments with. Our current status is that we launched our Genesis block 2 months ago. We invite you to come and to download it at zenprotocol.com, start using our software, to start playing with it, and to see how this thing actually is working in production. The second thing that we'd like to do is we'd like to invite partnerships. Anyone who is from an industry where they think that there's an asset that could have a large efficiency gain by increasing the liquidity of those assets, such as whatever, I gave the example of wine. I'm in talks with some other people from various industries where there's a competitive advantage by creating liquidity. So if you guys are in the market or could know someone or would like to get in the market of creating liquidity on instruments that actually would benefit from the liquidity premium, then please come to contact us at info@zenprotocol.com. Please put the title of that's why you're contacting us, so we make sure to notice. And we're also looking to hire people. So if you're a developer, we're looking for developers, and we're looking for people who are in the marketing and biz dev sectors. So please also feel free to contact us at info@zenprotocol.com. Thank you very much. I appreciate your time.